Alright, time for another draftphysics.com, debatephysics.com also, video presentation. So another video by icansciencethat, and it's it's a fundamental argument, but he's probably not going to get it right. I mean, he makes the mistake of saying springs versus momentum, and it's KE versus momentum, frankly. Springs obviously store something that's called momentum. Whatever you put in, you're going to get back in terms of an MV. Well, the ideal is you get back what you put in, but it doesn't really happen because springs can't give back all their energy unless you keep the object tied to a spring. So Hooke's law is pretty old and pretty famous in terms of the oscillation of a spring, and the energy's proportional, twice the stretch and three times the stretch, twice, three times the energy. A simple way of understanding the argument is to understand that you could have a scale, and just something as simple as mass you put one weight on it, you get 1 unit of compression. You put a second weight on it, you get 2 units of compression, indicating that these are two independent objects that have the same capacity to impose force, and clearly it's measured as 2, not 4 units of compression. There's no evidence that the 2 units is 4 units of anything. Alright, and so in that context, let's play the crappy video, see what he does to it. So of course we have cartoons to start with again. This is physics is childish for children. Serious people shouldn't be doing it.
Welcome back to I Can Science That, where we've been investigating the concepts of momentum and work.
Investigating is not the same as evading. So, they're two different words, evading and investigating. What you've done so far is evade the subjects entirely.
We've been working with a little thought experiment using springs to accelerate masses along a little sliding surface.
So, and the subject is not whether or not you can get twice the velocity. The subject is there twice the energy created by the friction. And so again, evading the subject.
If you're just joining us now, the original thought experiment involves launching identical masses with different speeds. And what we find is that launching with twice the speed results in sliding 4 times the distance.
Because of the friction, because the high velocity means you're spending less time on the surface, just a fact, and gravity is a time-dependent force. So again, the subject is gravity a time-dependent force or a distant-dependent force? Now, an obvious, again, statement is that it's obviously in the formula, the time dependency. It's 9.8 meters per second of increase in your velocity in 1 second units. 1 second units, not 10 second units, not squared second units, 1 second units. That's the subject, and you just keep evading the subject.
An interesting question that comes up there is that if that is twice the momentum, how could it be 4 times the work?
It isn't. That's the simple answer. It's not 4 times the work, because you didn't make 4 times the heat. You didn't actually have 4 times the abrasion. You didn't do 4 times the work. You didn't knock down 4 times the pins. You only knocked down twice as many.
What is it that a spring has in it that we're releasing here? Are we releasing momentum, or are we releasing...
Well, obviously momentum is in kinetic energy. The MV is the same MV. That's momentum. And the only question is your fabulistic squared function actually happen somewhere? Does it actually do work? And every single experiment demonstrates it doesn't do any work at all.
Work. Let's look at it this way. If I took one spring and that gave me 1 unit of momentum, would 2 springs be enough to deliver this 2 units of momentum? I think that's a really interesting question because...
Okay, it'd be nice if, yes, physics did all these experiments. But again, the point is if you go twice the velocity, let's say I double the springs here, I will get something like twice the velocity, be a little bit less. And the little bit less part is because the springs can't deliver all their energy. They're still moving when the object leaves. Now, how many times have I said this in videos? Anybody watching this channel knows I've said this over and over and over. The first of the videos I made, challenging physics to debunk me, is the video about how springs function. And that when you're releasing, when it's collecting the energy, it's always in contact, and so it's very efficient at collecting energy. But when it releases it, the spring is still moving when the object leaves the spring, which means the spring still has energy to give, and it can't make contact, so it can't give it. So it's stuck inside the spring, and the spring will oscillate, demonstrating it still has energy in it. That's the argument. You're going to keep evading it with this nonsense and say, okay, blah, 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 blah. And you have to acknowledge that, well, yeah, we'd like to have idealizations, but we don't have them. Springs aren't an idealization.
Perhaps the 2 springs would only deliver 2 units of energy and then would fall short of my 4-meter slide. Let's see if we can use just the principles of momentum and this one standard spring, this top spring, as a standard. See if we can apply 2 of those to get twice the speed out of our block. So we'll start with just the one standard spring and our 1 kilogram mass, and we've agreed that this is going to launch us at 1 meter per second. And that's 1 kilogram meter per second of momentum.
So he's just ignoring the subject. The subject is how you're taking the energy from the object. You're giving it a velocity. And then you're saying, let's extract all of the energy and stop it from moving. And what we want to do is measure how much energy was extracted. And it's going to be extracted through friction. And you're just paying no attention to the subject. You're saying the friction is constant, the same friction here as here. And the simple argument is no, the box actually weighed less when it was starting because it was going pretty fast. So per inch, it weighed less. It put less pressure on the surface. And this last little millimeter it moved, it weighed its maximum. And you're just ignoring that subject. You're evading it. Because I've said it over and over and over, and you're not referencing the fact that I've said it over and over and over. You're pretending you're responding to my argument when you're evading my argument.
So what are we going to do to try to get this block going twice the speed? Now, the hypothesis here is that 2 springs would deliver enough momentum to double the speed of our...
It's Hooke's law that that's what it will happen because it's twice the capacity to push. So that's all it is twice. It's not 4 times.
Our block. But we can't just assume that that's true. This is a mathematical exploration.
No, fuck that right there then. It should be an experimental exploration. The idea is to demonstrate it with evidence, not to keep proselytizing your theory. So you're just going to keep doing your theory and saying, that's all I have to do. Bullshit.
If you will. So we can't assume that answer because we do have a competing hypothesis. The competing hypothesis is that 2 springs delivers twice the energy. And we know that we need 4 times the energy.
So we don't know that. So again, he keeps stating that the distance is the way you calculate how much work it does, and the distance doesn't do that because the friction isn't the same. Obviously, if you're extracting less energy from the object, it has more energy to go further. Duh. So again, he's just ignoring the entire subject. It's just such a propagandizing liar.
To get twice the speed. So what is it that two springs are going to do? My first thought here is let's just take two springs on two identical masses and just launch them at the same time.
Oh, geez. Why? What? You don't think anybody in the audience is smart enough to say, well, fuck that. We already know that's going to be the same thing. So what's the point of this stupid comparison?
I now have 2 kilograms, and each one is launched by a separate spring. So I know that each one should be launched at 1 meter per second. Now that gives me twice the momentum. However, I didn't get one mass moving at twice the velocity. I got 2 masses moving at 1 velocity. But I think we can definitely agree this should work with our standard spring that we've agreed.
If we concede, look, you have to always conserve momentum. You've conceded that point. So why not start with the conservation of momentum and then explain where the added or missing kinetic energy is? Because the momentum always works. It always makes rational sense.
Absolutely works. So 2 springs can deliver twice the momentum.
So the point is that it doesn't quite work, okay? That if you're going to make a spring comparison, when you increase the velocity, the spring becomes less efficient. So it will lose a little bit of that energy. And a little bit could be 10%, could be 15%. So it's not insignificant depending on what velocities you're pushing things at.
But this isn't the configuration I was going for. So
yes, we want 1 spring compressed twice as much, or 2 springs pushing 1 object.
So my next thought was to launch them in sequence. Let's launch that first block. That should get the first block up to 1 meter per second. That's half the speed we need. Now if I just bump it with another mass, I could bump it and transfer in that other meter per second that I need of velocity. So I'll just launch another mass after it with another of my standard springs.
I'll wait till it stops and then do the same thing over again and pretend that's twice the speed. Too ridiculous.
Only that's not going to work because the first mass has 1 meter per second and the second mass also has 1 meter per second. So that second mass is never going to catch up. We're not going to get a bump out of that. What we've ended up with is, once again, 2 individual masses moving each with 1 meter per second.
So again, let's just recognize that all that he has to do is provide some evidence that friction comes in units of distance, not units of time. That's it. So he just has to explain how he knows there's 4 times. When it goes 4 times the distance, there's 4 times the heat in the surface. I mean, I've already said all this. I mean, that's the whole point of Joule. That's the whole point, of recognizing that the collecting energy, measuring energy is a difficult task. That's why Joule is famous. It's because he came up with a way of doing it that was much more reliable. And so the whole argument is what is your claim? You're claiming there's 4 times the energy in the surface, that's 4 times as hot. Do you have any evidence indicating that you've tested that ever? And of course the answer is no.
Per second. And that's still 2 springs gave us twice the momentum, but it is still in the 2 masses, 1 velocity configuration. So my next thought is that if I use 2 springs to launch 2...
Oh, what the hell is this crap? Shit. This is just so... Let's just make it more and more convoluted. I mean, obviously, you now put the springs in series, and so obviously they're going to compress half as much, and all you're going to do is this spring is going to release, it's going to compress this spring. You're just complicating a simple experiment.
Masses.
You can't compress this spring realistically unless you're holding all of these springs are being compressed. So you don't even have a description of how you're creating this spring compression.
I can then use some more springs to separate the masses. So we'll start off if we launch the two blocks with two springs, we know that that should be able to generate 2 kilogram meters per second of momentum, but that's in the two masses 1 meter per second. What we have here is this mass is moving at 1 meter per second, and this mass is also moving at 1 meter per second.
You can't put springs between the two objects that aren't compressed and then claim you're gaining some sort of energy advantage. So the spring can't produce anything if it's not compressed.
What I need to accomplish now is I want to get an additional meter per second into this mass, and I'm going to need something to push against, but I've got my other mass here. I can now push against this other mass. If I push with the two springs, I can get another 2 kilogram meters per second.
Obviously, you can't get that, all right? So again, this is the brick wall argument. They're saying that if I push the block against a brick wall and then release just one block, that it'll go the same velocity that if I push 2 blocks into each other with the spring in the middle. Obviously, as the spring expanding in both directions, it's going to be half the velocity going each direction. And when there's only one way the spring can expand, there's going to be twice the velocity. So it's just, again, this needs you to prove it with experimental evidence. You need to show us some evidence of how springs work. Doing this crap, telling me what your silly theory is meaningless. Cite an experiment.
Second out of this thing, and I've got 2 kilograms, and I need 1 meter per second for each one. I just have to push them in opposite directions this time. If I push 1 meter per second this way on this mass, I can use that to transfer the momentum to this mass by pushing 1 meter per second this way on this mass. So by firing those 2 springs.
So again, this is the free momentum argument. Now, when you're pushing the opposite way, that means you're going to have a counter force against motion. And so you're only going to get 3 units, let's just say. So instead of your 4 units of energy, you're only going to get 3. But it's just, this is just so convoluted. Why bother with this nonsense?
To transfer 2 kilogram meters per second in opposite directions, 1 in each of the directions, I should be able to fling my final mass out. I will have left this mass with no momentum, and finally I now have my 2 kilogram meters per second on this mass in the configuration that I was looking for, which is one mass moving at 2 times the speed. I did it. And I did it using our standard...
You did it using 4 springs, which doesn't make any sense at all.
...combination of a spring and a mass. So the standard spring that can do 1 kilogram meter per second on 1 kilogram mass, I was able to use with a combination of them to generate 2 kilogram meters per second out of my final 1 mass.
All right, 1, 2, 3, 4. 4 springs.
However, it took 4 springs.
Yeah, duh. Yeah.
To pull it off. And the fact that that took 4 springs should give you a clue about what it is that springs deliver. Each individual spring delivers 1 unit of energy.
And so again, it won't happen in the first place because the very fact that you pushed against this object's motion with one of the springs means that you did use up the energy to stop it from moving. So it's just a fact you used up, okay, half the energy of the spring. So you're only going to get a half unit of velocity out of that spring.
Not a full unit of momentum.
And again, he's ignoring friction here altogether. So we know in space it's not going to happen this way anyway because there's no friction. So to stop this, he had to push it against friction again.
If we were to simplify this down now that we know that, all we have to do to launch
So now he's going to say 4 spring compressions makes 4 units of distance, which 4 units of distance is only 2 units of energy, if we extract it properly. So again, ridiculous statement. Doesn't take 4 units of energy to move something twice as fast. It only takes 2. The scale proves it.
our 1 kilogram mass at 2 times the velocity is we're going to have to hook up 4 springs to it.
Nah, bullshit. So where's the experiment showing that? 4 springs makes only twice the velocity. Show me the experiment. Show me. There's no experiment to prove that. Won't even come close. So even with the inefficiencies of the springs, it's going to be way off.
But we need 4 springs to deliver twice the momentum to the same amount of mass.
Ridiculous.
That was a short one, but really, I think, pretty meaningful. What this
No evidence at all that 4 springs makes only twice the velocity. Again, it's just silly on its face. It's silly.
shows us with our thought experiment is that according to what we understand from our thought experiment, springs do not store momentum.
Springs violate Hooke's law. That's what he's basically saying. Screw Hooke's law. What does that have to do with physics? Like I said, look, the fact is if they do this experiment, it's not going to be 2. It's going to be 1.8 or something. And their prediction is 1.4. So it's always going to be way too much momentum to be consistent with their kinetic energy prediction. Okay, that twice the spring compression is not enough energy to move it twice as fast.
So they store units of energy. And that should, once again, tell you that this unit of...
In the same context, they're basically arguing that twice the compression of a spring is 4 times the energy. So it doesn't make any sense at all. One minute they're saying twice the spring compression can't make twice the velocity. And then they're saying that twice the spring compression is 4 times the energy. So it should be really easy to get twice the velocity.
Energy is a meaningful unit. That's what a spring is apparently doing according...
Apparently nothing. There's no evidence here. Again, this is just the Holy Ghost wears loafers. Okay. That's what I see. I can draw the loafers on the Holy Ghost's feet. There, I've proven it. No, you didn't prove shit.
To that thought experiment that we started with. We just followed it along.
Right, and now you came to the conclusion that it takes 4 springs to make something move twice as fast, and there's just no evidence on this fucking earth that that's true. None. Zero. Not absolute nonsense.
To our
a kid's pop gun proves that one wrong.
Natural conclusion here. But I thought since this was a fairly short one, I'd spend a little time to show the slightly more formal version of the mathematics behind this. Here's your warning. If you absolutely detest math, just skip to the end. But if you're just interested to see how we'll use the language of mathematics to explore the world, then feel free to...
So again, just useless videos. These are useless responses to any of the arguments being made. The accusations against your physics is that it's unevidenced, made-up, fictitious stories. And you have done nothing but make up a fictitious story.
Follow along. I'm going to start with Hooke's law. Hooke's law is pretty simple.
Yeah, and it doesn't have any 4 springs to go twice as fast in it.
And it's something that I think all the parties in this discussion have already agreed to. It just says that the amount of force you get out of a spring is directly proportional to how far you squish the spring.
Right, and he's just said the opposite is true. I need 4 times the force to go twice as fast. That's not what happens with springs. I want twice the force. Twice the force. I mean, again, he won't say, I think Isaac Newton was wrong when he developed his second law of physics, because right underneath the second law he says twice the motion, twice the force, 3 times the motion, 3 times the force. Well, that's not right. So have the balls to say Newton was wrong. He's claiming Newton was wrong. It doesn't work that way. You want to go twice the motion, you need 4 times the force. That's what he's saying. And he doesn't have the courage to say it. You know, attack the origin of the theory. Newton.
You squish the spring more, it pushes back harder. That's all it says. So, defining our terms pretty carefully here, we're going to push on the spring with force F. That will cause the spring to squish by this amount, delta X. And this K constant...
So he's using the word force, and it's right there. So clearly twice the force. Newton says twice the velocity. You're saying, no, I need 4 times the force to go twice the velocity. You just drew it, 4 springs. Again, right on its face. Can't anybody watching this video, can any viewer watching this video think it's absolutely true that it takes 4 springs to go twice the velocity? 4 times the force to go twice the velocity? You really believe it takes 25 times the force to go 5 times as fast? It's ridiculous mush.
Is the spring constant. That tells you how stiff the spring is. And that's just a constant, depends on the material of the spring and how big the spring is, what the spring's made of. You have stiffer springs and softer springs, that's all. So this particular spring has a spring constant of K, so when we apply this squishiness to it, that's how much force it's going to take to squish it that far. And of course, because of equal and opposite forces, that spring is pushing back on us. If we release the spring, it's going to push back and bounce back with that same amount of force that we were pushing. But there's a bit of a tricky...
So yes, the bit of the tricky part is if it's launching the object, that is, the object's going to leave the spring still has energy in it when it leaves. The spring still has energy in it when the object leaves. The spring still has energy in it when the object leaves the spring. The spring still has energy in it when the object leaves the spring. Again, I've been saying this for what, months and months and months. You know, since I figured it out, I said, oh shit, I didn't think of that, right? You know, that springs contact matters. You can't push on something if you're not touching it. Yeah. Duh.
Thing with that, and that is, as you release the spring, the delta X of the spring's compression shrinks. Right? And this top one, this is what delta X was. So this is the force we had from that spring. But then as it starts to unwind, the force gets less and less until it finally...
So this is just complete bullshit. Obviously the force of the spring, it's going faster and faster. So it's accelerating through the whole process. And then the object leaves, and the spring is still in the accelerating mode, but now it doesn't have the capacity to accelerate anymore, so it's going to start decelerating.
Finally reaches 0 when the spring is completely extended again. That's how the force works according to Hooke's law, and the work equation that we've been working with, the equation for work we agreed was the force times the distance. So we might be inclined to say...
So again, he just keeps arguing the same nonsense, that distance is always reliable, and it's not. But whatever, fine.
That this is the amount of force right here, and this is the amount of distance. But the problem with that is the force is not consistent as the distance shrinks, right? The force starts reducing as the distance shrinks down. So in order to equate how much work we get out of the...
It doesn't matter. There's a net amount of force in the spring. That's the basic argument. There's a net amount. You compressed it a certain amount. You put a certain amount of force in. It's a net amount. And the only question is does all of the net amount get out of the spring? And the simple argument is obviously not, because the spring's still moving. After the object leaves, the spring is still moving. That means it still has energy in it. So it's like the oscillating ball in the example I gave, right? The 10-minute video they won't respond to. The ball is oscillating. I throw it at a brick wall and it's not oscillating. It comes off the wall, it's oscillating. Obviously that oscillation is not linear motion. And it has to be made out of the energy that went in. Can't be made out of anything else. There's no other source of energy. So obviously you can't get as much back in linear motion because some of the linear motion is doing this now. I mean, these aren't complicated arguments, you know, to have somebody just quote that and then explain how I'm wrong. That the oscillating ball hasn't trapped energy as non-linear motion. Of course, it's trapped energy as nonlinear motion.
Entire spring, or how much work we had to put in to squishing the spring, we're going to have to use a little calculus. We're going to have to integrate. And so the equation we can write is the integration form of...
What a nonsense. So go ahead and do all that. Do all your integration. And what's the conclusion going to be? I mean, it's just ridiculous nonsense.
Work, where force is a function of x. Because it is a function of x, we can't just multiply it times the displacement. We have to integrate that function over the range from zero displacement. From zero displacement, we'll integrate over to x and see how much work we put into this spring. So let's do that. I'm just going to replace the force with the equation that we agreed to, and the k here we said was a constant. That's a constant, so we don't need that inside the integral. Here we have our integral ready to go. And we're doing calculus right now in our house. So if you're in high school calculus, feel free to follow along. The integral of x dx is 1/2 x squared. And there's our constant out there. And at plus c, right? Don't forget, you're going to get a point off in math class if you don't remember to put the plus c. And then we said our integral is over the range from 0 to delta x. So I just indicated that right there. And what that just means is we need to plug in this formula where x is delta x and subtract where x is 0. The subtraction, thankfully, just makes the c's drop out. And this term was 0, so that one drops out completely. And we're left with simple equation. The amount of work we put into a spring is proportional to the square of the displacement. And what is this equation telling us? What is this?
So this is just absolute bullshit. So again, he didn't do any integrals. He didn't take the tiniest distance and do all the integrals. He just sit there and figured out a way to unintegral his integral, by taking all the features out of it. To come up with the same fucking equation that isn't Hooke's law, by the way, right? I mean, so this is like the law of the lever. They can lie and square things, but that's not the original law. The law is, this isn't Hooke's law's original conclusion. Hooke's law original conclusion is the work equals the change in the momentum, period. There's no 1/2 k times your x. It's just the x part matters. Twice the velocity, twice the compression. But again, their problem is they never thought about the fact that springs don't give back all their energy. So you're not going to give all that you put in.
Saying, it just says simply, the more you compress a spring, the more work that spring is storing. And if you care, it's proportional to the square of the amount of displacement. The interesting thing about this is that this is consistent. There's a consistent number that has nothing to do with the amount of mass that is on that spring. So that's the work stored in a spring and how we got it.
Right. How fast you fall in gravity doesn't have anything to do with your mass either. But falling 4 times the distance is only 2 units of time. So again, you just keep ignoring the catch. The catch is it's 4 units of distance, but it's 2 units of time. And the force is in units of time. Just like paint spray, just like water in a river, they're all time-dependent forces. Wind, sandblaster, doesn't matter. They're all time-dependent. There's a certain amount of force through a certain amount of time. Period.
Let's look at this from a different perspective. I would like to calculate how much momentum is stored in the spring. Because remember, the whole question we started with was whether a spring stores energy or stores momentum. If the spring stores momentum, how much momentum is that? So in order to have some momentum, we're going to need a mass. So I'm going to put a mass of mass m. The little blue thing now has mass m. I put on the end of my spring. And it's going to be experiencing this force from the spring pushing it. And as the compression of the spring comes out, the force is going to reduce. And what we're going to need to do is integrate that force to calculate the final velocity of the mass. And based on that.
So again, theoretically, it should be twice, because that's all it takes to compress the spring in gravity, is twice the weight. So again, this is just such bullshit. Momentum is weight, frankly. It's the same thing. Turn the scale sideways, you can create exactly the same spring compression using a synthetic force.
We'll know the momentum. Right? We know that the force is just going to come from Hooke's law. We know that acceleration is just going to come from F equals ma. And this is the momentum ultimately that we are looking for. So let's jump right in. The acceleration, we know by definition here, is the second derivative of the position. The second derivative of position is the first derivative of the velocity. So we could just say, acceleration is dv dt, which just says, the rate of change of velocity with respect to time. So we had written that before as, the change in velocity.
So it's just the change in the momentum is exactly that, the change in the velocity. That's what Newton said. Twice the force, twice the motion. The motion is the velocity portion. Obviously, it's twice the momentum. It's not even close to complicated, and they're doing this just to complicate it.
Divided by how long it took to make that change. Now, in calculus, we have this lovely chain rule we can apply. That the problem with this right here is I don't want to integrate over time. I want to integrate over displacement, right? I want the spring to come out, and I don't actually know how long that's going to take. I know how much displacement that is. So I want to integrate.
So he didn't do any of that to prove any of that he knows any of those things, how long it's going to take. That's, again, the catch. They're going to say it takes 4 times the time for the spring to unravel when it's going twice as fast. And it's not going to take 4 times the time. It's going to take twice the time.
Integrate over x. I don't want to integrate over time. So I'm going to apply this little chain rule here. The dv dt is the same thing as dv dx, dx dt. Dx dt is, in fact, velocity. That's v. So I can rewrite acceleration as v times dv dx. So I'm going to do that. And while I'm at it, I'm going to move the dx on over to the other side. So we get...
So he's just changing gravity. For example, if he was talking about gravity, he just changed the second into distance. He's now saying that the gravity happens in units of distance instead of units of time. And obviously it doesn't happen in any consistent way in units of distance. That's why Galileo found out 1, 3, 5, 7. You get a whole bunch of free distance because of your accrued velocity. So he's pretending that none of that accrued velocity exists anymore. And he's just going to say 1 unit of distance, 1 unit of force. And it's not 1 unit of distance, 1 unit of force.
A fairly simple looking expression that just says a dx equals v dv. Now, I think the next thing I'm going to want to do, I'm going to integrate that. Let's go ahead and integrate that. And we should recognize, we've been seeing this one before, v dv, well, that's 1/2 v squared. And for the a dx, a is a function of x, so let's go ahead and fill that in. What is it? A is f over m, and f is k delta x. So we're going to have k delta x over m for our a and our 1/2 v squared. And you'll see that I've dropped the plus c's, but on the previous slide, we know where those go, so I didn't feel like we had to keep dragging those along. K and m are both constants, so I pulled them out. And now I have, again, this very friendly integral, which by now I recognize.
Right, so all of this, right, to try to disprove Newton's clean statement of twice the force, twice the motion, 3 times the force, 3 times the motion.
As 1/2 x squared. And on the interval from 0 to delta x, that is 1/2, here's our 1/2, delta x squared, and our constant k over m equals 1/2 v squared. Wonderful. Got rid of all those nasty integrals, got all those dt's out of there. What am I trying to do? I'm trying to get momentum, which is mass times velocity. So let's take this thing.
So we know you're not trying to get momentum. You're trying to rationalize nonsense. That it takes 4 springs to move something twice as fast, and it doesn't. You have no experimental evidence demonstrating that 4 springs create only twice the velocity. You have no evidence.
And solve it for velocity. The 1/2s, we can drop those, and then we just have to square root both sides. So that's pretty straightforward. The velocity is the square root of k over m times delta x. That's pretty good, but momentum is mass times velocity, so let's multiply mass on there. So we'll have, instead, the momentum is the square root of mk times the displacement. There you go. That is the amount of momentum stored in a spring. The insight that we get by looking at that.
So it says you. So again, this is presuming, okay, that there's no friction, first off. You're pushing something in space. Well, you're only going to get twice the velocity and twice the, distance then. So all of this mush doesn't apply to any real circumstance. And again, there's just no friction in this at all. No recognition that if you're pushing an object where you're going to extract its energy, you're not going to get that 4 times the distance thing if you're not extracting the energy. And it's the fact that you're varying the extraction rate is the only reason why it goes 4 times the distance. It only goes 4 times the distance because you're changing how much energy you're taking out of it. When it's going fast, it weighs less. It applies less pressure to the surface. Duh.
That piece of math there is that the amount of momentum stored in the spring depends on the mass. It's proportional to the square root of the mass that's sitting on the spring. If we change out the mass, we're going to get a different momentum. And those who didn't want to look at the math can join us again for the summary. What did we discover?
All right, so they didn't discover anything, didn't prove anything, didn't show a single piece of experimental evidence defending any of this crap, this assumption that it takes 4 springs to make twice the energy. Too ridiculous, too silly, doesn't happen anywhere in this universe ever. All right, and he just said it like it's a truth.
What we just discovered was that the momentum stored in a spring is different depending on what mass you're trying to accelerate with that spring. On the other hand, the amount of energy...
All right, so we know that's not true. So he's got it exactly backwards. It's the kinetic energy that gets very inconsistent. The momentums has to be very consistent. You can't have an amount of force in the spring and say, well, depending on what I'm shooting, I have a different amount of energy in my spring. Well, it's just not true.
That we store...
That's not Hooke's law.
...in the spring has nothing to do with the mass at all. And this tells us simply that springs store energy, they do not store momentum.
Oh, you're such a liar. Yeah. So again, his proof is that 4 springs, you need 4 springs to go twice as fast. That's his assertion. There's no physical evidence indicating that's true. None. Zero. Nada. Nothing. It's not anywhere in this universe are you going to find that circumstance to be true. So it's just an overt lie. He just made up this fucking fact, and it's the premise of his retarded argument. It's not true, asshole. It doesn't take 4 times the energy to go twice as fast. It doesn't take 9 times the energy to go 3 times as fast. It doesn't take 16 times the energy to go 4 times as fast. And it doesn't take 25 times the energy to go fucking 5 times as fast. You have no experimental evidence demonstrating this crap to have anything to do with reality, and yet you make these videos. In this childish way, by the way. Trying to basically molest the neurology of children. You're a fucking child molester.
The energy can be turned into momentum. Absolutely, we can use that energy to accelerate that mass. But the amount of momentum you're going to get depends on what mass you put on the spring.
It's just so ridiculous a statement. The force decides based on the force decides how the explosive. The dynamite decides how explosive it is based on what mass is in front of it. Not even close to the truth.
A compressed spring holds a consistent amount of energy, no matter what mass you put on there. But that the amount of momentum...
Okay, it's just he's got it completely backwards. The kinetic energy is a fable. It doesn't do any work. It will not participate in the experiment in any way. It's just a made-up fable, scalar woo-woo. And the fact is, the momentum will always be conserved. So he's just such a fucking liar.
That you're holding in that spring we don't know how much momentum that is until you put a mass on there. Tell me how much mass it is, and I'll tell you how much momentum you're likely to get out of this thing. So this difference...
Says a Ewa.
...here, this dependency on mass, leads to an excellent idea for a practical experiment.
Oh, look at that. He's going to do a practical experiment or suggest one. So you've had 350 years to do the fucking experiments. Why haven't you done any of them? I mean, could you just answer that question? You've had 350 years to shore up your theory of 4 springs to go twice as fast. So why don't you show me where you did the experiment the 350 years? You've had 350 years to do it. Where's your experiment?
We've seen it play out here today in this thought experiment. You could do a practical experiment. You could take a spring, compress it to a fixed amount of compression, and then push on different...
Yeah, this has all been done. And the results are pretty dramatic in terms of, it doesn't work. The fact is you get a different amount of momentum, okay, depending on how light the objects are you put on top of the spring. And that's because of the spring's failure. Because the spring loses contact with the thing it's pushing before it's gotten all the energy in. But the fact remains that deficit in total momentum is still in the experiment. It's still in the spring. You can figure it out that, okay, I know where it is. You're the one arguing that somehow I put a 5 mass connected to another 5 mass, I get a 10 mass going half the velocity, and your claim is that half the kinetic energy is gone. But do you demonstrate where it went? Is there any place it is? No, it isn't any place. You're just making it up. I mean, these people are just such hypocritical douches.
Masses with that same spring. Compress the spring, put a mass on it, measure how much velocity you get out of that mass. Take the same spring to the...
Twice the force, twice the motion. 3 times the force, 3 times the motion. That's Newton's statement. So say you're disagreeing with Newton. Please, say those words. Be honest. And say Newton was wrong. Say it, you coward.
Same compression and launch a different amount of mass and see how much velocity you get out of it. Does the velocity vary according to the square root of the mass? And if it does, I think...
So again, they've had 300 years to do an experiment, and he's suggesting we should do it instead. Why haven't you done it? Why haven't you proven your theory? You're claiming it's true. Why don't you have any evidence proving it's true? It's ridiculous. Ridiculous duplicity and hypocrisy. You know, to pretend you don't have to produce any evidence at all. Nothing. You claim it and you don't prove it.
I think you'll see that you have verified this hypothesis, and that's exactly how you could do that, to take that into the real world.
All right, so this is why science sucks. This is so bad as science, right? I don't have to prove anything. I don't have to demonstrate it. I don't have to connect it to a real experiment. I'll just tell you there's quarks. I'll tell you there's entanglement. I'll tell you there's all this crap, and I won't be able to take a picture of any of it. There's 400 weirdo particles inside of atoms somewhere, all hiding. There's a bunch of antimatter, a bunch of other crap. The whole thing is absolute crappy nonsense. None of that shit exists. The whole thing is just such a pile of bullshit. They just made up all of this physics. It's all made up rubbish. They don't have any real hard evidence for any of their assertions.
Maybe you're so averse to math that you don't want to look at these.
Yeah, whatever. It's not averse to math. Your math, you just showed what your math was. You're trying to take one thing and convert it into another thing. So you tried to convert a time-dependent force, gravity, into a distance-dependent force. And that's all you did. You showed us how I can manipulate it and change what it looks like. Yeah, that's what you demonstrated. But you didn't demonstrate you did anything honest.
Expressions, these equations. Well, let me remind you, we did this with our thought experiment. We found that with our standard spring that's able to push a 1 kilogram mass up to 1 meter per second, it took 4 of them to...
Okay, so it didn't take 4 to get twice the velocity. So it's just a lie. He has no experimental evidence. It takes 4 springs to go twice as fast. None. Zero. Nada. Complete bullshit. Just absolute bullshit, really. 3 springs will be more than twice the velocity.
To send that 1 kilogram mass down the slide at 2 meters per second. And that's because springs store energy.
All right, so again, just right there, that's all you need to see, right? That's his claim. 4 springs to go twice as fast. 3 springs to go what? 1.7 as fast? Wait, what's his silly argument? And it's a silly fucking argument. 2 springs, you only go 1.4. You only gain 0.4. You have a whole new spring doing the same work, and yet somehow that spring only has 0.4 to add. So the one spring adds 1, and the other spring only adds 0.4. Again, it doesn't happen, and it's not Newton's physics, clearly. And this weasel won't man up to either one of those arguments. He won't man up to the statement that he's arguing against Newton. He's saying Newton was wrong, overtly. And he won't man up and show any fucking evidence.
Not momentum.
Just the bullshit. Yes, you're all fucking... You people have spent way too much time watching cartoons. Cartoon physics. So anyway, another crappy, shitty, off-the-subject fucking piece of crap as an argument provided by a physicist. Another evasive, weaselly piece of shit. That doesn't even get to anywhere close to showing us any evidence of anything. Fuck this planet. Well, it's already fucked, but it's unfortunately fucking us good guys because of these bad guys. Because of their bad behavior, the good people have to suffer.